To try to understand what a conservative vector field might look like, let's remember that if a vector field is conservative and is causing motion along some path C where C is closed, a closed path is going to be one where the ending point is the same as the initial point. A conservative vector field is going to have a potential function, and the fundamental theorem of line integrals says that this work can be calculated by plugging the endpoint into the potential function, and then subtract from that the initial point being plugged in. But if the endpoint is the same as the initial point, then this subtraction is going to yield 0. So if we have a conservative vector field on a closed path, the work done moving it along that path is going to be 0. So let's consider the graph of this vector field, and let's consider an object moving along a closed path somewhere in this field. And let's also say that we are traveling around this curve C in a counterclockwise direction. If we look at these force vectors, we see that they are generally in the same direction as the displacement vectors. And if we think about the angle in between the force vector and a displacement vector, when that angle is less than 90 degrees, we know that positive work is being done. We can look at any of these force vectors around this vector field, and most of the time they're acting in the same direction as the displacement. So if the work done by this vector field is primarily positive, then we're going to say that it's not conservative. The work would need to turn out to be 0 in order to be a conservative vector field. Let's take a look at another example inside a different vector field. Again, we're going to move along a path C. Again, let's move counterclockwise. Now in this vector field, we have some vectors that are moving generally in the same direction as the displacement, while other vectors are moving in a direction that is somewhat against displacement. In this region, we have angles theta that are bigger than 90 degrees. And if the angle between force and displacement is bigger than 90 degrees, then we say that negative work is being done. So in this region up here, we're generally seeing negative work, but in this region down here, we're generally seeing positive work. So the negative work in this region is going to cancel out with the positive work in this region. And the net result would be that the work done moving an object along the entire path C would turn out to be 0. And therefore this vector field does look like it could be conservative.